Okay, so Unit 8, Part 2 focuses on being able to find the solutions of quadratic equations. Now, if you remember back to solutions, it's one of the 4 acronyms for x-intercepts. So we have roots, zeros, x-intercepts, and solutions. That being said, yes, there is a calculator way to find solutions, and we'll really talk about that later on. We're going to learn 3 different strategies to do it by different formulas. And again, this is just to prepare you for worst case scenario. They actually force you to use one of these 3. So the most complicated one, and honestly the one we grew up with the most, was the quadratic formula. Now, keep in mind, I know as crazy as it looks, it's not something you have to have memorized because they do give it to you on the star chart. It's underneath the quadratic section. It says quadratic formula, and it literally lays out like this. The hard part is, do you know how to use it? So that's what we're going to practice today. So the quadratic formula stems from having your quadratic equation in standard form. So like this, ax squared plus bx plus c, where we're going to use the a, b, and c values. Okay, so let me break down the formula for you. So yes, this says negative b, but it really means like if b is positive, it's going to be negative. But if b is negative, then it's going to turn into a positive because a negative times a negative is a positive. So how I interpret it is this doesn't say negative b, it says the opposite of b. So whatever b is, you got to think the opposite. But we'll practice both ways. Plus and minus, and we'll talk about the reason why there's both. The square root of b squared minus 4 times a times c all over 2 times a. Okay, so I'm honestly just going to jump in because once you get the hang of it, it gets pretty easy. We're going to combine this with simplifying radicals, which is what we did yesterday. So I just want to show you that connection there. So if you look at number 1, it's already in standard form and it's set equal to 0. That's what we want for this entire unit, okay? So there's no math involved there. All we're going to do now is figure out what our a, b, and c values are. So our a value is 1 because when there's nothing in front of the variable, it's an invisible 1. B is positive 10 and c is negative 2. Okay, so that's the first step. Now we're going to plug into our formula. So I'm going to have this template on the assignment as well, just to help you get your feet in the water. But you have to realize that on the STAR test, it's not going to be set up for you like this. You have to know how to utilize it. So if we look at the first one, so negative b, so the b value is 10, so we're going to plug that there, plus minus the square root of b squared, which is 10, minus 4 times a, which is 1, times c, which is negative 2, okay? All over 2 times 1 again. So that's being able to plug in into the formula for quadratic formula, okay? Now we're going to simplify that. And so what I mean by simplify is just kind of clean it up. So again, we start here. The negative 10 is just negative 10, so nothing happens there. Plus and minus. Now here's where we want to clean this up. So 2 ways to do it. I can do it in my head, or we can rely on the calculator. Now, if we're looking into vocabulary, we don't focus in on it too much in 8th grade, but you may see it in Algebra 2 or Pre-Cal. This underneath the radical has a word for it, and to be honest, I can go into depth, but it's kind of too much to talk about right now. This is your discriminant, and this is something that's part of it, but I can explain that later. So what we want to clean up is underneath the radical, okay? So the traditional way to clean up the radical is literally putting everything in parentheses where I plugged in a number, but we're just going to type in what I see. So 10 squared minus 4, and don't forget that is a minus, not a negative 4, times 1 times negative 2. That's simple, just like that, okay? So we get a value of 108. You should not get a negative. We're going to see what happens when you do get a negative, but right now it is a positive. And then the denominator is just 2 times 1, which is 2. Now, we can stop there. Most of the time, that's all they want you to do is simplify it. But we connect it to what we do in yesterday. So we're going to look at the radical right here. So the square root of 108, we don't want the decimal form. We want to simplify it. So what that means is we have to figure out what the highest perfect square that goes into 108. So if I do kind of like trial and error till I find a perfect square, there it is. My perfect square is 36 and 3 are my factors. 36 is that perfect square that we're going to take the square root of. So I'm going to bring that out of the radical. So let's rewrite this. It's negative 10 plus minus 6 square root of 3, because the 3 stays underneath the radical, all over 2, okay? And that's another way to take it further. Now, you can take it even further than that, and it gets not necessarily complicated. It's just, can I divide both of these terms by 2? So can negative 10 divide by 2? It can. Negative 10 divided by 2 is negative 5, plus or minus 6 divided by 2 is 3, and then the square root of 3. And that's as far as I can take it. So 3 different levels, if you think of it that way. Yes, this is okay, and yes, we can stop right there. This is maybe where they want you to take it further into the EOC, and then this is the furthest you can take it by simplifying that denominator, and that's it, okay? So that's the hard part. The next part is just figuring out what my solutions are. If you remember a traditional quadratic crosses the x-axis twice. Okay, most quadratics do. It's possible for it to cross once if it touches and bounces back, and it's possible for it to touch 0 times because it kind of looks like it's floating in the air, okay? So this is where the quadratic formula helps me find where it crosses the x-axis. So there's a reason why there's a plus and a minus. The plus involves the positive solution, and the minus involves the negative solution. Doesn't matter which one I do first. So what I'm going to do is literally type in this, okay, as intended. So negative 5 plus first, 3, the square root of 3. So I literally just did the same problem, but with the addition sign. And then I've got a long and crazy decimal, and that's what the quadratic formula does. It gives you the most exact answer you can get. And we're going to round to the tens place, so it would be 0.2. Now, since we did the plus, it's our positive solution, okay? If we do the same thing, but I'm going to change that plus to a minus because we want the negative side of it, okay, I get my negative solution. So it's negative 10.2. Now, what are these two numbers? That's where the parabola crosses the x-axis at negative 10.2 and 0.2. Let's do that again. So if I look at, we're going to skip if I look at number 2. Okay, so we're going to explain number 2, not skip it, because I need to talk about it. So if you look at number 2, the equation itself is not in standard form. We want A, B, and C value to all be on one side, and we want it to set equal to 0. So how do I do that? Well, think of it like solving equations. I want to move everything to the left. So to move this positive 20 over to the left, I'm going to subtract 20 to both sides. When I subtract 20, it doesn't have the same last name as either of these. So it's just x squared minus 8x minus 20 equals 0. And that's it. But don't just put 20, you have to move it by adding or subtracting. So my A value is 1, the B value is negative 8, so watch your signs, and C value is negative 20. And that's why it matters what your signs are. If we plug into the formula, okay, B is negative 8. So this is the first time we're seeing negative 8. We'll talk about that in a minute. B is negative 8 again, minus 4A times C, which is negative 20, and then 2 times 1. So you got to know how to use the formula. Then we're going to simplify it. So this is where we have to be careful. A negative times a negative 8 changes it to a positive 8. So that's why I refer to it as the opposite of B, because even though it was negative to begin with, the opposite of negative 8 is positive 8. Plus and minus, we want to clean up underneath the radical. Now this is where you want to be careful because of the negative 8 squared. See, if I just type in negative 8 squared, I get negative 64. But technically negative 8 squared is negative 8 times negative 8, which results in a positive 64, okay? So just my tip to you is anytime you're squaring something, put it in parentheses, minus 4 times 1 times negative 20. And we get positive 144. And then underneath the denominator, 2 times 1 is 2, okay? Now let's clean this up. So just like before, I can stop right there. It's totally fine. We're going to go further and simplify. So this is what we did yesterday. Now, if you notice, the square root of 144 is already a perfect square. So if I try to simplify it, the square root of 144 is 12. And it does that. There's no radical left because it's not a non-perfect square, it's a perfect square. So then I can stop here, or I can simplify even further. Do both of these numbers divide by 2? Well, 8 divided by 2 is 4, and 12 divided by 2 is 6. There it is. So it doesn't matter what level you stop at, but you have to be prepared for any of these. Now, when I go to look at my negative and positive solution, this is a lot less complicated than these. So all I have to do is do the addition and subtraction. So 4 plus 6 is 10. There's my positive solution. 4 minus 6 is negative 2. That means my parabola is going to cross at negative 2 and positive 10. So let's do some more. Now that's like best case scenarios. So this is why the quadratic formula works with every single type of quadratic. But if we look at number 3, it's already in standard form, okay? So my A value is 1, my B value is 6, my C value is 10. If I plug into my formula, B is 6. So the opposite of B plus or minus the square root of 6 squared minus 4 times 1 times 10 times 2 times 1, or over 2 times 1. Now let's clean that up. Negative times 6 is negative 6, which is why I refer to it as opposite of B, because it's opposite of positive 6, which ends up being negative 6. Let's clean up underneath the radical. So because 6 is positive, I don't necessarily have to put it in parentheses, so 6 squared is fine. Minus 4 times 1 times 10. Now I get a negative 4. And then denominator is 2 times 1, which is 2. Now, this one I want you to put a star by. It won't happen on your assignment, but this is an example of a special kind. It is not possible to take the square root of a negative number. So, because no number times itself is going to get negative 4. Now, you might think, well, what about negative 2 times negative 2? Think about it. Negative 2 times negative 2 is positive 4. So, it's not possible. And you can't do negative 2 times positive 2 because they have to be the same. So, it is not possible to simplify this. So, what do? Well, how do I figure out what my solutions are? This is where you would honestly stop here because you can't go any further. Well, you can't go any further. So we're going to stop right there. Now we're going to type this in. If you look at it, it looks like one large fraction. So we're going to type it in like a fraction, alpha y1. We're going to do the plus first. So negative 6 plus the square root of negative 4 over 2. Typed it in just like I wrote it. I know I did the math right. This has to be right. But when I go to hit enter, it says error, non-real answers, okay? It's not possible to take the square root of a negative number. So it does not have a positive solution. If I try the negative and I change it to a minus, okay, it does the same thing because, again, I cannot take the square root of negative 4. So it doesn't have a negative solution. Well, what does that mean? Well, think about it. I talked about the 3 types of solutions where it can be 2, it can be 1, and it can be none. So this is one of those examples where the parabola is not going to cross the x-axis at all. It's going to float in the air, whether pointing up or pointing down. So this one has no solutions. It doesn't have any zeros. And that's rarely happens, but it does happen, okay? Let's keep going. So if I look at number 4, it's already in standard form. So we just have to take the ABC value. A is negative 1, B is 7, C is negative 3. If I plug in, B is 7, negative 1 is A, C is negative 3, and 2 is negative 1. So watch your signs. So negative times 7 is negative 7. Plus or minus, if I clean up the denominator, because 7 is positive, I don't need to put it in parentheses. Minus 4 times negative 1 times negative 3. And we get a positive 37. So I know this one is going to have some solutions. And 2 times negative 1 is negative 2. Okay. Now, again, we can stop right there. But if you want to take it further, we're going to simplify this radical. So if I simplify this radical, and honestly does not simplify because 37 is a prime number, which means there is no perfect square that will go into it. It's only 1 in 37. So honestly, I can't take it any further. So my tip to you, honestly, just to save time, would honestly be just stop here and don't worry about simplifying. Just be prepared for future reference. If I type this in, just like we did the last one, we're going to type it in like one large fraction. So I got negative 7. We're going to do the positive side first, the square root of 37 over negative 2. So I'll literally type it in just like I wrote it. Hit enter. It gives you a long and crazy decimal. Now, I'm not saying you're going to get a long and crazy decimal every single time, but with some quadratics it will be. We're going to round to the tens place. So the positive solution is 0.5. Okay. Let's do the same thing. Now, instead of me having to go through and type that again, if I go up to shade it and hit enter, it'll copy and paste it. And don't delete. We're just going to hover over the positive and we're going to change it to a minus. Now you're like, Miss, how is it that I did a negative, but it gave me a positive answer? It's just one of those weird things that happens because of the square and because of the b value. So as long as you know that you did the math correctly, you trust the calculator to do it for you. I know it's going to cross the x-axis at 0.5 and 6.5, so something like that. It's just going to happen. So not necessarily going to give you a negative solution, but it's the negative solution because I put in the minus sign. If I look at number 5, notice it's not in standard form. It's kind of wonky looking. I want it to be in ax squared plus bx plus c equals 0. So if I want to move the negative x squared over to the left, we're going to add it. So it's going to become positive x squared. The 2x stays 2x. And then I want to move the 7 over, so I got to subtract it because it's already positive. So be careful with your signs, okay? A is 1, B is 2, C is negative 7. Then we're going to plug B is 2, B is 2, 1 is A, C is negative 7, and 1 is A. Let's clean that up because that's your first part is your assignment is can you plug in your numbers. Let's clean it up. Negative 2 is just negative 2 plus minus 2 squared minus 4 times 1 times negative 7. We get positive 32. So because I know it's a positive, I'm going to get some solutions over 2. Now again, we can stop here or we can take it one step further and try to simplify the radical. So let's go ahead and do that. The highest perfect square that goes into 32 is 16 and 2, 16 being my perfect square. So I know it's going to be negative 2 plus or minus. The square root of 16 is 4, so that comes outside of the radical, square root of 2, all over 2. Now technically, I can take this further, but I'm going to stop right there, okay? So we're going to type this in, just like one large fraction. So we're going to do alpha y1. Okay, I did the positive first, so I get 1.8. We're going to copy and paste it, and then I'm going to do the minus sign next. So my negative value is negative 3.8, okay? If I look at number 6, then we're going to do same thing. It's already in standard form, so A is 2, B is 5, C is 4. B is 5, B is 5, A is 2, C is 4, 2, A is 2. Clean it up, so negative 5 is just negative 5. 5 squared minus 4 times 2 times 4. The radical would be negative 7 here. So already, let me make sure I did my math right. Already I know it's going to be a no solution because of a negative radical all over 4. No matter what I try, it's not going to work. So this is going to be one of those where it has no solutions. It's not going to cross the x-axis. If I look at number 7, this is the hardest it's going to get where there's lots of stuff going on. Again, I want it to be in standard form, ax squared plus bx plus c. So this x squared got 3x squared, x squared. I want to move this x squared over here by subtracting 1x squared. 3x squared minus 1x squared is 2x squared. I want to move the 2x over by adding 2x because it's already negative. So 7x plus 2x is 9x. And then I want to move this 15 over. Since it's positive, I got to subtract it. And then that equals 0. Okay, so steps involved, got to be careful. So A is 2, B is 9, C is negative 15. That's why it's important you watch your signs. So B is 9, B is 9, 4, 2 is A, C is negative 15, 2 is A. And then I plug it in. Let's simplify it. So negative 9 plus or minus 9 squared minus 4 times 2 times negative 15. I get 201. Since it is a positive, I know I'm going to get some solutions. And then 2 times 2 is 4. Now again, I can take this further. If I try to figure out what the highest perfect square is that goes into 201, and it could be that it's not because it could be a prime. And honestly, I just go until my 2 digits get closer together, so I know that I'm not going to get one. Yeah. So it doesn't have one because I noticed my numbers cross, so I can't. So this is an example of a prime, so that means I can't go any further, which means I can't simplify, and that's okay. But we're going to type it in just like this. So alpha y1 negative 9 plus the square root of 201 over 4, and the positive side would be 1.3. Copy and paste, and then I'll do the minus sign, and we get negative 5.8. Okay. So it seems like a crazy process, but that's not too difficult, especially when you rely on the calculator. Where you have to be careful is converting them to standard form to make sure your signs are correct. Otherwise, the whole math is wrong, okay?